everyone, welcome back to my channel. In this video, I am going to explain Prim's algorithm in very simple English. This topic is very important for data structure and algorithms, especially under the graph chapter. If you are a beginner and you feel graphs are confusing, don't worry at all. I will explain everything from basics slowly using simple words and examples. By the end of this video, you will clearly understand what Prim's algorithm is, why we use it, how it works step by step, how edges are selected, and how to solve an example manually. So let's start from the basics. Before learning Prim's algorithm, we must understand three basic ideas. First one is graph, weighted graph, and spanning tree. A graph is a collection of vertices, which is also called nodes, and edges, connection between nodes. When each edge has a value or cost, we call it a weighted graph. For example, the cost can represent distance, time, money. Now a spanning tree is a subgraph that connects all vertices, has no cycles, uses exactly -1 edges. What is the minimum spanning tree? Among all possible spanning trees, the one with the minimum total edge weight is called the minimum spanning tree. So in simple words, a minimum spanning tree connects all nodes with the least total cost. This is exactly why Prim's algorithm helps us to find. What is Prim's algorithm? Prim's algorithm is a greedy algorithm. Greedy means at each step we make the best local choice, hoping it leads to the best overall solution. Prim's algorithm starts from any one vertex, grows the tree one edge at a time, always select the minimum weight edge, and connect a visited vertex to an unvisited vertex. It continues until all vertices are included in the tree. The main purpose of Prim's algorithm is to find the minimum spanning tree and connect all vertices using minimum total weight. Now let's understand how Prim's algorithm works conceptually. Imagine you are building a road network. You already built roads to some cities. Now you want to connect a new city. You always choose the cheapest road available. Prim's algorithm works in the same way. It maintains two sets: visited vertices already in the tree, unvisited vertices not yet in the tree. At every step, look at all edges between visited and unvisited vertices. Pick the minimum weight edge and add it to the tree. Next, let's go through the step-by-step process of the algorithm. I will explain each step one by one with a simple example in mind. Let's write the steps clearly. First one is choose any vertex as the starting point. Second step is mark it as visited. Third step is from all edges connecting visited and unvisited vertices, choose the minimum weight edge. Next one is add that edge and vertex to the minimum spanning tree. Last step, repeat step 3 and 4 until all vertices are included. Finally, you get the minimum spanning tree. Now, let's understand Prim's algorithm step by step using this example. On the left side, we have the given weighted graph. On the right side, we have the final minimum spanning tree. Our goal is connect all vertices with the minimum total cost without forming any cycle. First step, choose a starting vertex. First, we select any one vertex as the starting point. Here I start from vertex A. Now vertex A is marked as visited. Second step is find minimum edge from A. Next, we look at all edges connected A. From A, edge A to B has weight 2, edge A to C has weight 3. Among these, the smallest weight is 2. So we select the edge A to B and add it to the spanning tree. Now vertices A and B are visited. Third step is choose the next minimum edge. Now we look at all edges that connect a visited vertex to an unvisited vertex. Possible edges are B to C with weight 1, A to C with weight 3 and B to D with weight 4. The smallest weight among these is 1. So we select the edge B to C. Now vertices A, B and C are visited. Fourth step is at the last vertex. Next, we again check the edges connecting visited vertices and unvisited one. Available edges are B to D with weight 4, C to D with weight 5. The smallest weight is 4. So we select B to D and add vertex D. Now all vertices are connected. Final step. At the point, the algorithm stops because all vertices are included. The select edges are A to B with weight 2, B to C with weight 1, B to D with weight 4. The total cost is 7. This forms the minimum spanning tree, which you can see on the right of the image. Our next topic is advantages of Prim's algorithm. First one is always produce a minimum spanning tree, which means guarantees the minimum total cost to connect all vertices. Next one, simple and easy to understand. Works step by step by choosing the smallest edge and beginner friendly compared to some other algorithms. Next one, efficient for dense graph. Performs better than Kruskal's algorithm when the graph has many edges. Fourth one is greedy approach reduce complexity. Makes a locally optimal choice at each step, leading to a global optimized solution. Flexible starting vertex. Can start from any node and the final minimum spanning tree cost remains the same. Last one is useful with priority queues. With data structures like helps, it becomes very fast. Let's move to disadvantages of Prim's algorithm. First one, works only on connected graph. If the graph is disconnected, Prim's algorithm cannot generate a minimum spanning tree. Next one, applicable only to undirected graph. Cannot be used for direct graphs. Third one, requires weighted graph. Without edge weights, the algorithm is meaningless. Next one, not suitable for sparse graph. Slower than Kruskal's algorithm when the number of edges is small. Next one, more complex implementation with priority queues. Optimized version need advanced data structure. Our next topic is real-world application of Prim's algorithm. First one, computer network design. Used to connect computers and servers with minimum cable cost. Next one, telecommunication networks. Minimize the cost of laying telephone or fiber optic cables. Third one, circuit design. Used to minimize wire length in integrated circuits. Next one, transportation system. Optimized railway or metro track layouts. Fifth one, road and highway constructions. helps plan roads connecting cities with minimal construction cost. Next one, electrical power grids, used to connect power station and substation efficiently. Let's look at some important rules and key points you must remember this algorithm. These rules help the algorithm work correctly and give the correct minimum spanning tree. First one, graph must be connected. Next one is graph must be undirected. Third one, graph must be weighted. Next one, no cycles allowed. Next one is always choose minimum weight edges. The last one, start node does not affect minimum spanning tree cost. Let's quick summarize what we learned today. Prim's algorithm helps us find a minimum spanning tree, connecting all points with the smallest total cost. It's different from Kruskal's because it starts from one vertex and grows step by step. Using a greedy approach, it always picks the edge with the least weight. It's especially efficient for dense graph and in optimized versions. It uses a priority queue to speed things up. This makes it very useful for real-world problems like designing networks, roads or electricity grids. So, that's the end of this video on Prim's algorithm. I hope this explanation helps you understand the concepts clearly. If you found this video useful, don't forget to like, share and subscribe to the channel. Thanks for watching and I will see you in the next video.